Hello all. In the series of covering SAT topics, this is our sixth video where we will learn about inequalities. So starting with inequalities, it's just like the equations, but there are some restrictions in inequalities. Like in equations, we can add, subtract, multiply or divide both the sides. But in inequalities, we can only add or subtract on both the sides. We can multiply or divide also, but that should be a constant but with restrictions. Any variable we will not multiply or divide on both the sides. Only we will multiply or divide only constants, and that too with some restrictions which we will discuss here. So suppose the first question we are having is 2x plus 5 greater than equal to 4x minus 9. Then how we will be solving this? See, if we subtract 4x from both the sides, then what we will be getting? 2x minus 4x, that is negative 2x plus 5 greater than equal to negative 9. Now what we can do? We can subtract 5 from both the sides. If we are subtracting 5 from both the sides, then what we will be getting? Negative 2x greater than equal to negative 14. Now here if you will see, we need to remove the negative signs. So to remove the negative signs, we can either multiply by negative 1 on both the sides, or we can either divide on both the sides by negative 1. So then we will be getting 2x on this side and 14 on this side. But remember, in inequalities, if we are multiplying or dividing both the sides by a negative number, then the sign of inequality will be reversed. So this is what I was talking about, some restrictions. So we will be getting, now we can divide both the sides by 2. 2 is a positive number, so that will not affect anything. So we can say x less than equal to 7. So that will be the answer. Now this is called as inequality notation. So first I'll write the restriction. So what is the restriction? If we multiply or divide a negative number on both sides of inequality, then the sign of inequality is reversed. Now what we have to do next is, see, we have to discuss types of representations of inequalities. So first is inequality notation, where we use these 4 signs. This is less than, equal to if any number is included, then greater than and greater than equal to if number is included. Number 2, after inequality notation, it's interval notation. So in interval notation, wherever any number is not included or infinite is there, we give this parenthesis, and if it is included, I'm writing in the same order. So if it is included, then it's like this. These 4 we use. Then number 3, number line notation. So what we do in number line notation, we will represent the same thing, same region in the number line as we got the solution, and we will give these 2. If any number is not included, then hollow circle, and if a number is included, then a solid circle like this. It is for included. So these are the 3 types of representation. We have seen inequality notation in this one. Now let's see how we do other 2. So we had x less than equal to 7, that we got the answer for the above question. And if you want to do it in number line notation and interval notation, then how we'll be doing? This can be written as x, this is the sign of belongs to. So x belongs to is less than equal to 7, that means negative infinity to 7. And as I said, always infinity or negative infinity is given with parenthesis. So negative infinity to 7, since 7 is included, so square bracket. Then in number line notation, how we can write this in number line notation? Suppose this is the number line we are having, 0, 1, 2, 3, 4, 5, 6, 7, 8, like this, and this side we are having negative 1, negative 2, negative 3, negative 4, negative 5, and since arrow is extending on both the sides, so it will be up to infinity on the right side and negative infinity on the left side. Now to represent the solution, either we can bolden the line with the same color, or we can use a different color. So how we'll be doing this? We have to do from 7 to negative infinity. So we'll start from here and we will do like this, and this is our representation. Since 7 was included, so we can give like this, and if we want, we can bolden a little more, so we can do like this. This is our answer in number line notation. Now this was the normal type of inequalities. Now we also get 2 more types of inequalities in compound inequalities or combination of inequalities, that is called as. So compound inequalities. So in compound inequalities, how we will be getting the questions are, suppose the question is 5 x minus 1 greater than equal to 9 and less than suppose 24. Then how we'll be doing this? See here, this is read as 5x minus 1 greater than equal to 9 and less than 24. So we can write this as, we will solve this and we will add 1 on both the sides and all the sides. So you will be getting 5x minus 1 plus 1 greater than equal to 9 plus 1 less than 24 plus 1. So we can get 5x greater than equal to 10 and less than 25. So we can divide by 5. So we'll be getting x greater than equal to 2 less than 5. Now the same we can represent in number line or interval notation. Now this is the one type where and was there. Now the next type is where or will be there, like 2x minus 3 less than equal to 5, or we can take 3x minus 1 greater than equal to suppose 14. Then what we can do here, this implies that we can solve it as 2x less than equal to 5 plus 3. That means we are adding 3 to both the sides. So 5 plus 3. Here we will be adding 1 both the sides. So 3x greater than equal to 14 plus 1. So we are getting 2x less than equal to 8 or 3x greater than equal to 15. From here we will be getting x less than equal to 4 or x greater than equal to 5. So here or is coming. Or means we can take the maximum numbers. That means it is union, and means intersection. That means only we can take the common solutions. Here we will take the maximum possible solution. So like it will be clear from interval notation. In the last one we can write x belongs to just 2 to 5. 5 was not included, so parenthesis. Here we can write this as x belongs to, see, less than equal to 4. That means negative infinity to 4, and or is placed by union, that is u side, and then 5 to infinity. So this is how we solve the questions of inequalities. Now next we have to do is absolute value equations and inequalities in the same video. So first we will see absolute value equations. So in absolute value equations, what we have to know is, see, suppose it's written as absolute value x equal to a or absolute value x minus a equal to b. Then what is the meaning of these two is, so we always have to remember one thing, that the result of an absolute value is always positive. Why so? Because see, if we define absolute value geometrically, then the first statement means value of x at a distance of a from origin, and it means value of x at a distance of b from, here it's not origin but it's point a, from a. So you can see here, since a and b are the distance and distance cannot be negative ever, so since distance can never be negative, that's why the result of an absolute value is always positive. The result is positive but value of x can be negative. So like if we are having, whether it is absolute value 2, the value will be 2, absolute value negative 2 is also 2, because it just represents the distance. Absolute value 2 means distance from the origin to 2. Then absolute value negative 2 means a distance from the origin to negative 2. That is 2 only. That's why it is always positive. Now we get different types of questions on this, like we are having absolute value x minus 2 equal to 9. Then how we will be doing this? See, as I said, absolute value always gives the positive numbers, and it means that distance from the, like it's written minus 2, that means distance from 2, I mean the points which are at a distance of 9 from 2. So what we will be doing, it can be 2 points either on left side or on right side. That's why we'll remove this absolute value symbol with positive and negative sign both. So we will be getting x minus 2 is equal to plus minus 9. So this implies that we will add 2 on both the sides. So we will be getting x equal to plus minus 9 plus 2. When we will operate with positive sign, we will be getting x equal to 11. When we will operate with negative sign, we will be getting negative 9 plus 2, that is negative 7. So these are the answers. So we just have to remember that when it is absolute value x minus a equal to b, we can write x minus a is equal to plus minus b, and we always have to remember that b is always a positive number. Next, suppose we are having absolute value x minus 3 equal to -1. So in this case, see, result is given as negative, which is not possible. So it will not have any solution. No value of x is possible which can give us a negative result for the absolute value. So this is how we solve the questions of absolute value. Now let's take variables both the sides. So suppose we are having absolute value 2x minus 3 is equal to suppose 3x. Then if variables are both the sides, then we don't know the value of x. So after solving, we always have to check whether it is giving us the right solution or not. So how will we doing? 2x minus 3 is equal to plus minus 3x. So we can write 2x minus 3 equal to x, or 2x minus 3 equal to minus 3x. Here we will subtract px from both the sides and add 3 on both the sides. So we will be getting 2x minus 3x is equal to 3. So we are getting negative x equal to 3, or this implies that x equal to negative 3. From here we will be getting, we will add 3 on both the sides and add 3x also. So we will be getting 2x plus 3x equal to 3. This implies that 5x equal to 3, and we will be getting 5x equal to 3. So x will be equal to 3 over 5. Now we have to check both if they both are satisfying or not. So if you will see, when you will put x equal to negative 3, the right side will become negative 9, and as I said, result cannot be negative. That means this one is not satisfying, but x equal to 3 over 5 will satisfy. So only the answer will be hence x equal to 3 over 5. So when the variables are there on the right side also, we can say outside of absolute value also, then we always have to check our solutions after solving, because there can be some extraneous solution which can be rejected. Now coming to absolute value inequalities. So in absolute value inequalities, we only have to remember two things. They are just like formula. So suppose first is, if it is absolute value x minus a less than b or less than equal to b, it's same for both. So it can be written as x minus a greater than negative b and less than b. The second one, absolute value x minus a greater than b, then this can be written as x minus a less than negative b or x minus a greater than positive b. So these are the two methods which we need to remember. Let's do a question. We will do a question where a combination of both will be available. Suppose the question is absolute value 2x minus 3 greater than equal to 1 and less than equal to 13. Just take less than 13. Then what we will be getting? We can divide this problem into two parts. One part where we can write 2x minus 3, it's greater than equal to 1, so greater than equal to 1, and absolute value 2x minus 3 is less than 30. Now we will solve both the parts and we will find the common solution only between them, because it's and there. So we'll solve on the left side, and we can solve this as using the second formula, 2x minus 3 greater than equal to 1 or 2x minus 3 less than equal to negative 1. So we'll be getting, we'll add 3 on both the sides. So we can get 2x greater than equal to 4, or here we will be getting 2x less than equal to negative 1 plus 3, that is 2. So from here we are getting x greater than equal to 2 or x less than equal to 1. So always remember, it's easy to find the common solution using interval notation here. So how we will be writing here? We can write here x belongs to negative infinity to 1 union 2 to infinity. Now we will solve the second one. So this can be written as 2x minus 3 greater than negative 13 or less than 13. So what we will be doing here? This implies that 2x greater than negative 13 plus 3 and less than 13 plus. So we can get from here 2x greater than negative 10 and less than 16. So this implies that x greater than negative 5 less than 8. That means from here what we are getting, this can be written as x belongs to negative 5 to 8, and both of them are not included. So only parenthesis. Now whenever we need to find the common solution, if we can see easily, then that is fine. If we are not able to see, then we can use the number line method. So we will only plot these points which are the numbers or fractions, whatever it will come. So we'll start plotting from least to most. So least is negative 5, so negative 5, then 1, then 2, and then 8. So how we'll be doing here? First solution says negative infinity to 1 and then 2 to infinity. Negative infinity to 1 where 1 is also included, and then 2 to infinity where 2 is included. And the second solution says negative 5 to 8. So negative 5 which is not included to 8 which is also not included, and we only have to choose the common solution. So this one is the common solution. So final answer here we can write as, hence we will be writing in both the ways. So we can say in inequality notation it can be written as x greater than negative 5 but less than equal to 1, or x greater than equal to 2 but less than 8. If you want to do it in interval notation, then we can write x belongs to negative 5 to 1 where 1 is included, or 2 to 8 where 2 is included. So this is our final answer. So these are the different types of question which we can get, and if you will see, there will come this type of question also. Suppose absolute value 2x minus 3 greater than equal to negative 2. This is one type of question. Then next is absolute value, suppose we are taking this in the same way, 2x minus 3 less than equal to negative 2. So here you can see it's saying greater than equal to negative 2. Then we know that 2x minus 3 is always positive. The result of an absolute value is always positive. That means if it is greater than equal to negative 2, so we can say solution will be all real numbers because it is always true. But here it's saying less than equal to negative 2, which is not possible because absolute value can never be negative. So here it will be no solution. So that's it in inequality. We will meet again in the next video of this series. Thank you.